Welcome for today's topic, semiconductor. When we talk about the semiconductor, should we think that whether it carries the current or not? Let us see what happens. We know that there are two types of elements, conductors and bad conductors, or we say that insulators. Conductors are having one electron in the last orbit. Those are the silver, copper, gold. These are the conductors which can easily carry the current. Second group is insulators, which are having 8 elements in the last orbit. 8 electrons in the last orbit. It means that they are having the complete octet. So in between this conductors and bad conductors or insulators, one more group of element which is called as semiconductor, which carries the current but at this particular temperature, or you can say after supplying some heat. Semiconductors are the silicon, germanium, etc. So suppose consider silicon and germanium. These are the semiconductor. Now we know that insulators are having 8 electrons in the last orbit. Conductors are having 1 electron in the last orbit. Semiconductors are having 4 electrons in the last orbit. Means valency of these semiconductors are 4. What the structure exactly? Let us see. Suppose we consider a semiconductor crystal. Let us consider silicon. This is silicon atom. Now, as I told you that there are 4 electrons in the last orbit, it means that they can donate the electrons, accept the electrons, or one more best option is they can share the electrons. So what the silicon atoms do? Suppose this is an atom of silicon. There are 4 electrons. So these are 4 electrons in the silicon atom, and it requires 4 more electrons to become stable. The neighboring atom of this, suppose this is one more silicon atom which is neighboring of this is second, this is third, and here is one more. Now here are 5 silicon atoms we can see, and these 5 silicon atoms shares electrons with each other. See this. Now we can see that each atom shares 1 electron with the neighboring atom, and thus suppose we consider this silicon, this atom. If we consider this atom, the octet of the atom is completed by sharing 1 electron with each silicon atom. Now this is the condition where this one atom shares electron with another neighboring atoms and becomes stable. Now there is no need to give, no need to accept, nothing to do, and it remains as stable atom. But only till the normal temperature, means only at the normal temperature it remains as an stable crystal or stable atom. When we supply heat to the same, suppose this is the crystal and we supply some heat to the crystal, the electrons are bounded with each other. Some electrons are loosely bound and easily they absorb the energy and get free. Suppose this electron is loosely bound, which absorbs the energy, gets excited and become free. These electrons get energy, absorbs energy, get excited and become free. So this is your free electron. This is your free electron. If the electron is here, here should not be any electron. If there is no any electrons, means there is a lack of electron. If it is lack of electron, it means there is a formation of hole. What is this? This is a formation of Hole is nothing but the lack of electron. It needs one electron to be complete. Now this is hole, as we know that electron is of negative charge, and the hole, obviously when the negative charge comes out, the hole is created, and this is of positive charge. So we have seen that when we supply some thermal energy to any crystal, the loosely bound electron absorbs the energy, becomes excited, comes out and becomes free. Now this free electrons is ready to move in the crystal, or it moves in the crystal. Suppose one more electron, suppose this electron again absorbs some energy and getting free. So here is creation of hole with positive charge, and here is one more free electron with negative charge. Now what happens? This electron which are free in the crystal at after supplying some energy, after supplying some thermal energy, these electrons moves in the crystal, and after some time, suppose this electron moves in the crystal, after some time it comes here, as this is of positive charge, this positive charge acquires this electron, and here is the recombination. This hole acquires the electron, and the hole again, the place of hole is replaced by the electron. This free electrons now acquired by the hole. Now the process of acquiring the electron by the hole is called as recombination. What is it? It is recombination. When any hole acquires any electron, that process is called as recombination. Now there are more electrons present in the crystal. We note down one thing, that whenever we supply the thermal energy, there are equal number of holes and equal number of electrons are generated. It means that we can say that after supplying thermal energy, equal number of holes and electrons generated, that is pair of holes and electron generated. Here also we can see that the pair of holes and electron generated. Now these electrons are freely moving in the crystal. As I told you that it moves for some time. It moves for only few nanoseconds to some microseconds. Electron can easily or freely move in the crystal from few nanoseconds to from few microseconds. It means that from 10 to the power minus 9 seconds to 10 to the power minus 6 seconds. This much time only an electron can freely move in the crystal, and this time is called as lifetime of the crystal. The time from where it becomes free to it is recombined with the whole. The total time required to getting an electron free and to getting it acquired by the whole. This total time is called as the lifetime of the electron, which is in between 10 to the power minus 9 seconds to 10 to the power minus 6 seconds, few nanoseconds to few microseconds. This is the total lifetime of the electron. Now we are talking about the crystal, silicon crystal, which is a semiconductor, and this crystal creates some electrons and hole pairs after applying some thermal energy. This happens only in the pure type of semiconductor. Now this generated hole and electrons are very less. Even though at normal temperature it behaves as an insulator, when we supply some energy, the electrons are generated and the current carried, but as the number of holes and pairs are very less, the current flows through the semiconductor is very little. I said that pure semiconductor, it means that there must be impure semiconductors. As exactly there are one more type, there is one more type of semiconductor which is called as impure semiconductor. Now first we'll see what is, okay, we'll talk. Now we have seen that pure type of semiconductor, we have seen the crystal of silicon having all the elements of all the atoms of a single element. Now that is the pure type of semiconductor. Pure type of semiconductor is also called as intrinsic type of semiconductor. Intrinsic type of semiconductor, if one is pure, other must be impure type of semiconductor. Impure, and which is also called as extrinsic type of semiconductor. This extrinsic type of semiconductor is the gin of your gadgets. It is used in mobiles, laptops, computer, TV, and every electronic gadget, headphones, etc. Whatever you are using, in every electronic gadget, extrinsic type of semiconductor plays an important role, and because of only this we are having the digital world. So what is impure type of semiconductor? Now if impure type of semiconductor is there, there must be some impurity. And this impurity is whenever this impurity is added with the pure type of semiconductor, we get impure type of semiconductor, which is called as extrinsic type of semiconductor. This impurity is of two types. Impurity is of two types. I said that when we add some impurity in the pure type of semiconductor, we get the extrinsic type of semiconductor. Adding some impurity in pure semiconductor is called as doping, and this is very important process. Doping is nothing but adding some impurity. Adding impurity is called as doping. Whenever we add some impurity in pure type of semiconductor, we get extrinsic type of semiconductor. So this doping is of two types: pentavalent doping, and trivalent. Two type of doping is there: pentavalent and trivalent. With the name only we can understand that what is pentavalent and what is trivalent. As penta is 5, valent is valency. Here is tri is 3, valent is valency. So impurity is pentavalent impurity and trivalent impurity. 5 valency, it means that the elements which are having 5 electrons in the last orbit are having valency 5. Elements which are having 5 electrons in the last orbit is called as pentavalent impurity, and elements having having valency 3 is called as trivalent impurity. So when we add this type of impurity in the pure type of semiconductor, again we get two type of extrinsic semiconductor. It is first is N type of semiconductor and second is P type of semiconductor. N and P. After adding pentavalent impurity and trivalent impurity, we get two types of semiconductor, two type of extrinsic semiconductor, N type and P type. How? Let us see. We have considered pure semiconductor, we have considered the crystal of silicon while studying the pure semiconductor. Now we are talking about the extrinsic type of semiconductor. And as I told you, for getting the extrinsic type of semiconductor, we have to add some impurity in the intrinsic type of semiconductor, and we get that extrinsic. Now, as we have considered silicon crystal as a pure type of semiconductor, here also we consider the silicon crystal. Suppose this is silicon. This was the structure of a intrinsic semiconductor, where we have seen that each silicon crystal shares one electron with the neighboring silicon crystals and becomes stable. Now this is the pure crystal of semiconductor silicon, and we need extrinsic semiconductor, means we have to add some impurity in the crystal. And let us first will talk about the pentavalent impurity. Pentavalent elements are arsenic, aluminum, phosphorus. These are the pentavalent impurity, having 5 electrons in the last orbit. So when we dope some atoms of arsenic in the crystal of silicon, let us consider this atom. Instead of silicon, here we dope an atom of arsenic. Let us consider few more atoms of silicon which are sharing one electron with this arsenic, and here we see that this arsenic share one electron with the silicon atom. Now the question is, we know that arsenic having a pentavalent impurity. Pentavalent means there are 5 electrons in the last orbit, and if we see that there is 4 electrons of silicon crystal and only 4 electrons of arsenic, it means that there is one extra electron is there, which is free because it is not bonded with any atom. Because of adding pentavalent impurity, the octet of arsenic is completed by sharing 4 electrons of silicon, and 1 electron remains free. Now this free electron, as we know that electron is of negative charge, the formed crystal is of N type of semiconductor, N type of extrinsic semiconductor. Extrinsic semiconductor. See here, this crystal is having one extra electron which is of negative, electron is of negative charge, so the formed crystal is N type of extrinsic semiconductor, and this is one type of semiconductor. Now this crystal is ready to donate one electron because it is having one extra electron, so it can easily donate the electron. So this type of semiconductors, this type of impurity is also called as donor impurity. Why donor? Because it can donate electron. So this type of impurity is called as donor impurity, and the formed crystal having extra electrons, having free electrons, is called as N type of extrinsic semiconductor. Now we'll talk about the P type of extrinsic semiconductor. Now when we talk about the P type of semiconductor, extrinsic semiconductor, the impurity must be trivalent. Trivalent impurity means having 3 electrons in the last orbit. Now 3 electrons in the last orbit. Examples are boron, gallium, indium. Suppose we consider the crystal of boron or atom of boron. Now again we think the crystal of silicon. Suppose this is silicon crystal having 8 electron in each octet and it is stable one. Instead of this silicon crystal, we add the impurity of boron. Suppose this is your boron, but we know that boron is having 3 electrons in the last orbit and 4 electrons of silicon, means there is lack of one electron to complete the octet of boron. Here is hole. Obviously this is lack of electron. It is lack of electrons means this hole is of positive charge. Note down one thing, hole is always of positive charge. Here is one hole, here one hole is formed, so it is hole is of positive charge, so the formed crystal is of p type of semiconductor, p type of extrinsic semiconductor, extrinsic semiconductor. So this is the boron atom which were doped in silicon crystal, which shares electron with the neighboring silicon crystal, but there are 3 electrons in the last orbit of boron, and one and for because of that one hole is generated. That hole is the lack of electron which is of positive charge, so the formed crystal is p type of extrinsic semiconductor. As we know that hole is of positive charge and it is always ready to accept the electron. This hole is always ready to accept the electron, so this type of impurity is called as acceptor impurity. So this is the acceptor impurity because there is lack of hole and it easily acquire or easily acquire the electron. So this p type of semiconductor and n type of semiconductors are the 2 types of extrinsic semiconductor which are impure semiconductor and which are very useful, and because of this extrinsic semiconductor only we can communicate with each other with the help of mobile, with the help of phones, computer. So in today's lecture we have seen the semiconductors, types of semiconductors, pure and impure, that is intrinsic semiconductor and extrinsic semiconductor. Extrinsic semiconductors are again of 2 types, p type semiconductor and n type semiconductor.